quizzes yesterday. Put them into Infinite Campus during advisory, so they are now in Infinite Campus. But I do want to get started on our next section here. We're still looking at these trig functions. Today we're going to look at how to find a reference angle.
What's that?
We're going to go over what that is. So, alright, so if theta is a non-quadrantal angle in standard position, its referent angle, theta prime, that's what this little apostrophe means, it's a prime. See, if theta prime is the acute angle formed by the terminal side of theta and the x-axis. The rules for finding the measures of reference angles for theta between 0 and 360 degrees or theta between 0 and 2 pi are shown below. Again, these ones are in degrees, these ones are in radians. Okay, so 2 pi radians is the same as 360 degrees. And we did go over that before you guys left. So in quadrant 1, okay, quadrant 1, your reference angle is going to be the same as theta because it is between 0 and 90 degrees. It is an acute angle already. So theta prime is just going to be equal to theta. In quadrant 2, okay, quadrant 2 is this one over here on the left, upper left. To find theta prime, you'll either take 180 and subtract theta, the one you already know, or take pi and subtract theta. So it gives it to you in both degrees and radians on how to find theta prime. Okay, then quadrant 3 is that lower left-hand side. Okay, so quadrant 3 would be over here. To find theta prime, you will take theta and subtract 180 degrees, or take theta and subtract pi to find that reference angle. Last one is quadrant 4. That's the bottom right-hand quadrant. To find theta prime, you'll take 360, subtract theta, or take 2 pi and subtract theta. Okay, so those are different ways to find our reference angles. So you are going to need to know where your original theta angle is and in which quadrant so that you can find that reference angle using those formulas I highlighted. Now, if the measure of theta is greater than 360 degrees or less than 0. So if it is 400 degrees, okay, that's greater than 360. If it's less than 0, that would be like negative 10 degrees. So if you have a negative, then you have to use a coterminal angle with a positive measure between 0 and 360 degrees in order to find the reference angle. So we did find coterminal angles before. Okay, so that week before break, we found coterminal angles. That's when we added or subtracted 360 from our original. So we will have to do that if it is greater than 360 or less than 0. So we do have a few examples below here. Okay, so first thing we want to do is sketch the angle so we know which quadrant it's in, and then we can find the reference angle. So our theta value for this one is 330 degrees. Okay, so finding my angle, it's positive, so I go counterclockwise. Okay, again, this way, that's 180. Around to the y-axis, that would be 270. And then 330 would be somewhere around here. So my angle would be about there. Okay, which quadrant is that? Do you remember the quadrant directions?
4.
That is quadrant 4. Okay, so that's the one I highlighted orange. So those are the formulas I need to use to find my reference angle. So since I was given theta in degrees, I'll find theta prime in degrees. Okay, so theta prime. We'll take 360 and subtract our theta value, which is 330. Okay, so theta prime is equal to 30 degrees. So our reference angle for this one is 30 degrees. Okay, so that's why we want to draw it out so we know where that angle is. Your reference angle that you're finding is this acute angle right here. Okay, so this is where theta prime would be. It's between the angle that you made and the x-axis. Okay, so that one right there would be theta prime. The one you made all the way around is theta. Okay, next we have number 2. Now in this one, you're given this in radians. Okay, I know we haven't made our angles in radians before. It's not super difficult. So here along the x-axis, that would be 0. Okay, this would be pi over 2. This would be pi. This would be 3 pi over 2. Now, with the one that I have here, it's negative 5 pi over 6. Okay, so that's not quite pi, right? But we're also negative. Okay, that means my angle has to go clockwise. And since it's not quite pi, it's going to be somewhere around here. Okay, so to make it pi, that would have to be 6 pi over 6. And then it would be pi, but it's less than that, so not quite pi. Does that kind of make sense?
So
How I drew in? It's not quite pi.
What if it is pi?
Then you would make your angle right here, because this is pi. All right, so finding your reference angle, since theta is less than 0, okay, it's negative, that means I need to first find a coterminal angle. Okay, so we need to find this coterminal angle. Okay, to do that, we need to make it positive. Well, that means I would have to add 360 onto it, but it's not in degrees. In radians, what's the same as 360 degrees? How many radians is 360 degrees? What is this? 2 pi. 2 pi is the same as 360 degrees. So to find a coterminal angle in radians, you're going to add 2 pi to this negative 5 pi over 6. Okay, so I'm going to add 2 pi to negative 5 pi over 6. Now, when I do that, focus. When I do that, I need a common denominator since this 2 pi is over 1. Okay, so that means I need to multiply the numerator and denominator here by 6. So I have negative 5 pi over 6 plus 12 pi over 6. So now I can add together my 2 numerators. Okay, and what does that equal?
6.
7 pi over 6. Okay, so this is your coterminal angle. It's not your reference angle. Okay, so again, sometimes you need to first find this coterminal angle if it's less than 0 or over 360 or over 2 pi. So now, using our coterminal angle, we can find our reference angle, Which quadrant is this angle in?
3 to 12.
I had to get a common denominator. So I had to multiply this by 6. Whatever I do to the denominator, I have to do the numerator. So 6 times 2 is 12 pi over 6. Okay, which quadrant is this angle in?
3.
It is in quadrant 3. Okay, so that is the formula I highlighted pink. So we're looking at quadrant 3. So to find theta prime, since we are in radians, I'll use this one that's in radians. So we're going to take our theta value, which is our coterminal angle of 7 pi over 6, and subtract pi. Okay, again, pi is over 1. So again, I need a common denominator to subtract those two. So we have 7 pi over 6 minus 6 pi over 6. And what would my reference angle then equal? 1 pi over 6. Okay, and again, your reference angle is the angle created from the one you originally had in between the x-axis. So theta prime would be this angle right here. Okay, questions on number 2. So number 2 had an extra step. You first had to find the coterminal angle since it was negative. Okay, so you have this positive angle now. Then you could find the reference angle. All right, I want you guys to do 3 and 4. Do numbers 3 and 4, please. Three, 4.
No. Yes, it is. Because it's negative. That's what I did. Wait. No. That's right. Where's the clock from? Yes, sir.
Yeah. So when it's negative, you go clockwise.
That's what I told you. You said it was positive. I said it was negative. You're right. I did. And I'll say it again. That's 3, right? You get 3? You get it.
This is less than 0, so you have to use this first to find the coterminal angle. So if it's negative, you have to add 360 to get the coterminal angle.
It's 290.
It's 250. Question, what if we turn one into a positive and
You have to get the coterminal angle first, like you did in this one. So if that's negative coterminal angle, you need positive coterminal angle.
Always.
So you need to add on what to it?
180. 360.
So negative 1 times plus 360 to get theta. Oh yeah, you did. Yeah, that's right, 250. Now you can find your coterminal angle. Using 250
pi, 2 pi, 3 pi, 4 pi. Blue pi, red pi. I have a headache.
Make sure you do number 4 as well.
Where did 2 pi over 1 come from?
Hmm?
Where did 2 pi over 1 come from?
In number 2,
Yeah.
that was finding the coterminal angle. So 2 pi is the same as 360 degrees.
Yeah, 260.
So I had to find,
Four, the 360 versus 2 pi.
I had to find the positive coterminal angle with negative 5 pi over 6.
So like, for number 2, like where you put pi over 2 and pi and that, is that always going to be that?
You don't always have to do this.
No, like, above the arrow, above y.
Oh, these ones?
Yeah, those always could be that.
Yeah. So that's if you're positive, that's the direction it would go. If it's negative, it would go opposite
Yeah.
direction. Yeah. So if it's less than pi, it's going to be over here. If it's greater than pi, over here, or greater than 3 pi over 2 over here. So if you need to, what I would do in your calculator is see what decimal 3 pi over 2 is, and then see what decimal this is, and see if it's greater than that, or sometimes that's a little bit easier to look at.
I hate that. I might want
Well, 2 pi over 3 is less than pi.
Wait, it's 2 pi over 3, so it's just going to always. So
Not in the first one.
So it's in Q4.
This is going counterclockwise. It's positive. So it has to go this way.
Yeah, so it goes all the way.
No,
It's in the bottom right. Right?
no,
Bottom what?
it's not on the bottom.
It's only in the top.
It's in the top.
Yeah, let me know where you guys get this.
So it's to the right.
You go all the way around.
No, what's that?
So it'd be Q1.
No, Q high. Maybe high is Q.
Try using Q1. Try using any.
I don't understand. What is with the, like, half a pi and then the 3 pi back to?
This is in radians. So if I put this in degrees, this would be 90, this would be 180, this would be
So
270.
then what's 0 dash 2 pi?
This would be 360.
Why can't
But wouldn't that be 0?
It could be 0 as well, yeah.
Oh, did that
It
like
could
mean
also be
0 and
720.
2 pi? Like, does it mean like 0
Yes.
equals 2 pi?
Yes.
Oh, okay. I thought it was that's good. That's still what the hell I'm doing.
720 is 4
But
pi.
that's not 0.2.
What?
That number right there, that's not 2 pi.
Wait, 2 pi.
To the
Right
right.
side. To the right.
No, this is a column.
Oh.
Instead.
I mean, you guys didn't look at that, the right, the right one. We're on to the
This is 2 pi.
So this arrow just goes right into here, right?
Right where?
You know what I get math? 11.
Type in pi over
Okay.
600.
And that's driving nice. YouTube.
1.57. What is 2 pi over 3? That's greater than 1.57. So it has to go past that.
So we just go in here and halfway. So it's pi, right?
What? It's not just pi, it's 2 pi over 3. What are you talking about? Your reference angle?
Yeah, so it's going to be 2 pi over 3, and then it's going to be plus
Pi.
pi over 1.
Right, Bob?
No, it's in
So
quadrant.
it'd be 3 pi over 1. No, 3 pi over 3, right?
It's in quadrant 2,
Yes.
so you need to use pi minus theta.
So it's going to be 2 pi over 3 minus
3 pi over 3.
No.
Yeah, that's what you did for the last one.
So it'll be 3 pi over 3 minus 2 pi over 3.
3 pi over 3 plus 2.
I guess, I don't know. Isn't this the notes? Aren't you supposed to be giving us the notes?
Yeah, I wanted you to try it.
Well, I suck at it.
Yeah.
All right, so you can pay attention now as I go through it. So number 3, your angle theta is negative. If you have a negative angle, you need a coterminal angle. We did coterminal angles before. It was on your quiz. You had to find a coterminal angle that was positive and negative. For this, you have to have a positive coterminal angle. So since I have negative 110, that means I need to add 360 onto it, because then it goes in a full circle around. Okay, it's in the same position then. Okay, that's what coterminal means. So when I do that, I get 250 degrees. That is the theta that I want to use to find my reference angle. Now, my angle for either negative 110 or 250 is right here. That quadrant is quadrant 3. Okay, so I'm using quadrant 3. Again, that's the one that I highlighted pink. Okay, since I'm in degrees, I need to use this top formula here, since that has 180 degrees in it. So to find our reference angle, we're going to take theta, which is our coterminal angle, of 250. And we're going to subtract 180. Okay, so our reference angle is going to be 70 degrees. Number 4 is in radians. Now think of this as a fraction. It's 2/3 pi. That's what it is. That's what it's saying. It's 2/3 pi when you say 2 pi over 3. If it's 2/3 of pi, it's not a full pi, is it?
Yeah.
2/3 of a pi is not a full pi. It's less than a pi.
Yeah, it is.
Okay? Pi is over here. So that means it has to be less than pi. So it's going to be over here. Okay? This one right here is pi over 2. Okay? This is pi over 2. Now, if you don't understand radians, put it into degrees. We learned how to do that. Okay? To change it into degrees, you're just going to take it and multiply 180 over pi. Okay, figure out what that degree is. Then you can see where your angle is. Okay? When you are finding a reference angle, though, you do need to keep it in radians since it started in radians. Okay, if you're trying to figure out where it is on your graph, you can change it to degrees first. Okay? From here, since it is positive, it's less than 360, it's less than 2 pi. We are in quadrant 2. Okay, quadrant 2 is the one I highlighted blue. Okay, in quadrant 2, using our radians formula here, we're going to take pi minus our original angle, theta. Okay, so to find theta prime, we'll take pi, subtract 2 pi over 3. Now again, when you're subtracting fractions, you do need a common denominator. So I need to change this pi over 1 to 3 pi over 3. Okay, and I end up with pi over 3 as my reference angle.
It was 3 pi over 3. I kind of understand it.
Okay, so if you have a negative, that's the one that goes clockwise. You need a coterminal angle. That's what we did in 2 and 3. We found a coterminal angle that's positive in order to use these formulas. Okay? And again, if it's in radians, like these, find out what the degree measure is. So this is 360 divided by 3. So that's what, 120? So 120 is less than 180. It's greater than 90. That's why this is over here. Okay, so if you have to do it that way to find out where your angle is on your graph, do that. Same thing with this one. Do you have any questions on finding your reference angle? You're just using those formulas.